So now I propose that we move to the academic world. So I introduce Nicolas Audière from University Gustave Eiffel, and Nicolas is director of a COSIS lab, and the floor is yours, Nicolas, for 15 minutes as well. Thank you.
Thank you, Xavier. I'll let the colleague thank you for the invitation. With the slide coming, so I will speak about a program named Route 5e Génération, which has been developed since 12 years now. Try to give you an overview of what we do at a national level, but aligned with European activities. Next slide, please. So the question was, are we able to answer to the societal issues relating to the motorway, especially motorway mobility? This is the pitch. Next slide, please. So our goal was to, in fact, answer to the question that was asked by the FERL, the Federation of European Highway Research Laboratory, which is a European association based in Brussels. How should look like the fifth road generation? In fact, if you look at the history and the paradigm shift, you see that at the moment we are still at the era of the motorway, which was the fourth road generation. It was developed to increase the road safety as well as the speed of the vehicle, of the mobility, but it has important important environmental externalities. That is to say that it was aimed for individual car with our classical ICE engine. So if we want to move to another kind of mobility, decarbonized or low carbon mobility, maybe we have to invent a next new road generation. That was a pitch of the Forever Open Road program, which was a road infrastructure that takes the best of existing technologies and the best of those to come. Next slide, please. So this was the pitch of the Forever Open Road in 2011, made by Germany, Norway, and USA. It was the idea at 2011 that were in this scheme. So the idea was to build a prefabricated road, carbon-free, made of recycled materials, which was resilient to extreme weather conditions, which was able to fix and to repair cracks, so to self-repair itself. That was able to include a driver guidance system, measure its own conditions, that was able to guide the vehicle and to power vehicle. It was the idea of electric road system. This road was able to harvest and energy and to store energy. Okay, so heat storage, energy harvesting, and de-icing. So this concept also was able to capture CO2. So this concept was a winner in 2011 at the World Road Congress for road innovation, and we are still we have did this program in 2021, and I try to explain where we are heading now. Next slide, please. So the R5G program, or the Route 5e Génération program, is in fact the French declination of this Forever Road program. Next slide. And we ended with, in fact, was the idea of this project was to integrate different components of the Forever Open Road, following a systemic approach to design and build full-scale demonstrator of the next generation road. This was the scheme. So our goal was to develop a process to enable the demonstration of some key elements of this project. So it was divided in three phases. So individual components, demonstration, and deployment. And we are now at the third stage of we are the deployment stage of many solutions that was designed at 10 years ago, and we are still envisaging the demonstration of a recent one, like ERS or electric road systems. Next slide, please. So there is an animation. So the result, what is the result? Is that we are moving from VIC model, which is Vehicle Infrastructure Driver model, which is a classical design model of a motorway that was fixed in the 90s. And now we are moving to VI2E design model, when we have we have in fact four components: the vehicle, the energy, the infrastructure, and the information. In fact, why? In fact, information will with the idea of generalized information, and energy. In fact, the way to internalize the externalities related to the motor of the vehicle. So we have different key concepts. So positive energy road, electric road, connected road, and adaptable road. From a system point of view, it will be the way that should be designed the next generation of road. So we have, it is not a system like the VAC, it's more a system of system approach. Next slide, please. And so what we have to optimize is this system of systems, the SOS, VI2E, and in fact it paves the way for E plus C minus regulation on roads. So what we have to invent is a way to regulate this model, and it is enabling through the new interactions between the components of this next generation of roads. On the one side, on one hand, the energy integrated road produces, transfers decarbonized energy to road and street components, including the sensor and different system, and that generates E plus and C minus. On the other hand, the automated road generates C minus through the new function and services it implements. So at the moment, the research perspective we have on that is that we have to develop a framework for the environmental assessment, or even the LCA, so life cycle analysis of this system of systems. Next slide, please. So we are, and if I try to illustrate, in fact, the different demonstration and the way it is going, we try to illustrate what is happening on the country on different three aspects. Next, please. And it is what we call the fabric of road 5e génération, the R5G Fab, which aims to accelerate the project of territories. And so, in fact, we have been discussing and helping cities and territories since 12 years. And this diagram here shows you, in fact, the way we try to develop the R5G at this time at the network level. So if you take vertically, you have the scale of planning of the infrastructure. So we have the basin of mobility, the metropolis, the city, the block, and horizontally, you have, in fact, the transport infrastructure hierarchy. Okay, and so we have the trans-European network, we have the local network, the structural network, and the streets. And at each level, we have transformation to happen in order to move to the next generation of roads. And we have to not to forget the intermodal stations and also the ecological corridor. And I'll try to give you some example. Next slide. So, for example, if we are talking about peri-urban networks, we see a movement from multimodal motorways to road trains. And so at the moment, we have coaches on auxiliary lanes and carpool lanes. But with the deployment of automation and so on, we can imagine that we can have a mix between public transport and dense occupied automated vehicle so as to still increase the capacity of existing roads or existing peri-urban roads. And that was a dream. We can look at an old book named La Route Automatisée, which was published in the late 90s, and that was a precursor of our activities together with the VEDECOM. Next slide, please. If we are talking about long-haul transport networks, automation and decarbonization of freight transport of key elements. So I can give you, truck platooning is still an issue, especially could be a solution for the lack of driver, and also a key solution or key experiments are also electric road system, but I will let Pierre explain more in detail these activities in his slide. Next slide, please. On local networks, automation and decarbonization also key technology to improve the territorial supply. And we develop work to adapt road infrastructure to autonomous shuttles, and also look at how we can reuse low circulated train lines to develop new mobility solutions like the ferromobile solution. So have to have a automated road vehicle able to move on train lines, local train lines. That was 3 examples or 3 domains where we see the things happen, and automation and carbonization being enabling solutions to transform the mobility in these territories. Next slide, please, which is more prospective but more related to in fact another view. So we saw that we try to optimize the LCA of mobility, reducing the impact, improving energy, the availability of clean energy, but we can move forward. And what we try to develop now is to go to the next step. In fact, this VI2E framework is still insufficient, and we need to add the environment in which the road is located. So we have to improve, we have to include, in fact, the atmosphere and the green corridor in which the road is installed, in fact. So it creates, in fact, new interactions between these roads and its environment. And in particular, we have to deal with the decline of biodiversity, and we have to see how the road can be, next slide, please, can be, in fact, a solution to, in fact, capture CO2 emissions. So in fact, develop a road that consume or store CO2. So there is a reflection and topic to include in this area. Next slide, please. In parallel, we have to see how the road, in fact, can be a corridor or habitat for biodiversity. This is a European reflection on that topic. Next slide, please. And in this perspective, for example, we can consider that the system that equip the road can be used to monitor the state of the environment and biodiversity. For example, cameras and systems that are here to monitor fog episodes, for example, to ease, to secure, and to make a safe movement of vehicle, are also a solution to monitor the improvement of air quality and in the same time observe the consequence of the climate change on the territories. So it is in fact a way to how to use the infrastructure as a observatoire for climate change. Next slide, please. So I think I'm still on the time. We have what I wanted to say is that a new generation of road and street will increasingly automated and energy integrated so as to meet the societal challenges. Our F5G project was aimed to design demonstrator of the next gen roads. The different French regions, they are working on this direction, and especially the Île-de-France region. In intercity area, the challenge is not only to decarbonize long-distance freight transport. It is a major issue, but also we have to rethink the relation between freeways and territories and propose a better close approach between town and country. In urban environment, the challenge is to successfully transform urban arteries into health-positive streets. And in this context, we think that digital technology have to be seen as an essential solution alongside the development of new materials and processes to improve the resilience of road to climate and man-made hazards. Thank you for your attention, and thank you for the invitation.
Thank you very much, Nicolas.